I'm Doug Fern, and this is my take on music recording. The WPEN studios, where I started working when I was in high school, were built in 1947, before the era of tape machines. They had no way to record anything except by cutting a lacquer disc. This required a disc lathe, which was in the production studio. Lacquer discs were used for commercials, pre-recorded programs, news actualities, the sign-on and sign-off and other program elements, and to delay network programs. The disc lathe and the turntables throughout the 8 studios could accommodate up to 16-inch discs. Now, these single-use discs are sometimes called acetate, but they're actually coated with lacquer. Starts out as a flat aluminum disc, highly polished, onto which is coated the lacquer, which in its original form was actually from insect shells, but a synthetic version of it has been used for a long time. The actual substance is nitrocellulose, and the discs were available from 7-inch to 17-inch, although the largest commonly used are just 16-inch. A 16-inch lacquer disc could hold up to 30 minutes of program material at 33 1/3 RPM. The aluminum substrate of the lacquer disc has to be perfectly flat and polished. Otherwise, those irregularities will be reflected in the thin coating and make the disc unusable. The discs also have an additional hole for a second pin, which was used in some disc lathes in order to prevent the disc from slipping while it was being cut. More sophisticated disc lathes used a vacuum system to hold the disc in place. A disc cutting lathe is very different from a turntable. For one thing, the cutting stylus moves in a straight line versus a turntable where the stylus moves in an arc. That's a limiting factor in the playback quality, but carefully designed tone arms have an S-shaped curve to minimize the variation. The cutting stylus is made out of sapphire and ruby and ground to a chisel point. The playback stylus, on the other hand, is conical or elliptical to minimize wear on the disc. If you use a chisel point to play back the disc, you quickly destroy it. The stylus actually removes the lacquer in the groove. It just doesn't plow it to the sides. So consequently, a chip is produced, which must be removed by a vacuum system. It's called a chip, but it's actually a long, thin ribbon of the cut-out lacquer material. WPEN's disc lathe sat unused for about 15 years when I got there. I was fascinated by it, and I asked several engineers for help in using the lathe, but they all declined. Maybe they couldn't remember, or perhaps there was only one engineer who knew how to work the system, or maybe they just didn't want to be bothered. The lathe at that point had no stylus and no blank discs, but all the other paraphernalia to cut discs was there. Back in those days, there weren't the same kind of recording trade magazines as we have today. For one thing, there weren't very many of them, and for another, they were much more technical than the magazines we get today. I found in the back of one of the magazines manufacturer ads for companies that made the blank lacquer discs and also made the cutting styli. Both of the companies I used were on Long Island at the time, and the cutting styli was about $5, which would be about $40 in today's money, and 12-inch discs were around $3, which would be about $24 today. I ordered one stylus and a couple of discs, and I figured out how it all worked. But I didn't know how deep the groove should be. You can determine the depth by the width of the groove as you're cutting it, while looking at it through a microscope that was mounted on the lathe that had graduations that measured the actual width. You could actually watch the groove as you were cutting it, and as you adjusted the depth through a control on the lathe, you could see how wide the groove was getting. But in experimenting and learning how to do this, I cut too deep, which caused the stylus to hit the aluminum substrate, which immediately ruined the stylus. When I played back the disc, it sounded fine until it got to the point where it hit the aluminum, and then it was mostly just noise. So I ordered more supplies, refined my skills, and experimented with it. It never sounded great, and of course it was mono, because the radio stations were all mono at the time. The cutting head on the disc lathe was fed with a gigantic vacuum tube amplifier. The amplifier could put out several hundred watts because the cutting head required a lot of power. It wasn't very efficient. I really didn't have any practical use for cutting discs at the time I was at WPEN, but the experience was interesting and I learned a lot. Fast forward to around 1972, when my studio was still 4-track and we were looking to upgrade to 8-track, and I found a used Scully 1-inch 8-track at a studio in Philadelphia that was going out of business. So I bought their 8-track machine, but the owner was anxious to get rid of a lot of stuff that was there, and I ended up buying a lot of mics, mic stands, and other things that proved to be useful in my studio. And one thing he really wanted me to take was his disc cutting lathe. This was not the most sophisticated disc cutting lathe available at the time, but it was adequate for cutting demo records. It was a Presto 8N lathe, which actually had been used for mastering in some facilities for quite a while, but serious mastering was done on Neumann or Scully lathes. It wasn't really adequate for mastering because it lacked some of the features that a proper disc cutting lathe should have for mastering, and I'll talk about those in a minute. The disc lathe I got had a Grampian cutting head, which was very popular in the 1950s and 60s for cutting 45s. It had a very distinctive sound and could produce a very loud-sounding record. It also had some features that weren't on the disc lathe at WPEN, like a heated stylus. This was done with a small coil of wire that wrapped around the end of the stylus above the point where it touched the disc and had an electric current flowing through it to heat it. The heated stylus cut through the lacquer much more easily and was actually quite a bit quieter. The cutting head also had a silicon damping system that allowed it to follow any imperfections in the thickness of the lacquer disc, so the depth of the cut remained more uniform. The disc lathe came with quite a few lead screws. These were, as the name implies, a screw-type section of metal that you inserted into the lathe, and it determined how quickly record head would track across the disc. This, of course, determined how much time you would have in the recording. You always wanted to use the coarsest pitch that you could for a given length of time on the disc, because that allowed you to cut it at a higher level. The Presto 8N lathe was mainly aimed at broadcast use, and back before the era of tape, that was the only way you could record things, and most of the radio programs were cut on to 16-inch lacquer discs, half hour per side. One of the problems with cutting disc is that the outer diameter, the groove is moving beneath the stylus at a much higher rate than it is at the inner diameter at the end of the side. That meant the quality changed throughout. So the best quality was on the outer edge of the disc, and it deteriorated until you got to the inner part. The deterioration was mostly in a lack of high frequencies, but also it tended to be more noisy. Radio programs longer than a half hour required multiple discs, and when one ended and the next one began, there'd be an obvious change in quality. So one solution to this problem was to cut the first disc from the outside in, but then the next disc was cut from the inside out. A playback tone arm will track either way. It doesn't really matter. So when you did the segue from one disc to the other, it would go from the inner groove to the inner groove of the next disc, so the quality matched. And then when you got to the outside again, it would be the highest quality. And if you had to use another disc, then you'd start that one from the outside in. More sophisticated disc lathes used automatic equalization, which boosted the highs as you got closer to the center. There's another characteristic of all disc recording systems from the beginning, which boosted the highs as you were recording and correspondingly reduced those highs back to flat response on playback. This improved the signal-to-noise ratio significantly, but it did create some problems because now, suddenly, you could only record the very highest frequencies at a much lower level, since they were boosted about 20 dB in relation to something around 1 kilohertz. Also, low frequencies were attenuated by about 20 dB down at 20 hertz. This system works very well, but it creates problems for the disc cutting engineer because it sets a limit on how much high-frequency content you can have in the recording and still have it reproduced properly. The exact curve of this was really not standardized for decades, and it wasn't until the early 50s with a long-playing vinyl album that it became standardized as the RIAA curve that we know today. Mastering engineers also used limiters that actually were more sensitive to high frequencies than low, which compensated to a certain extent for the increased boost response. If you were recording for transfer to a vinyl record, you had to take all these and many more characteristics into consideration while you were recording to make a recording that would transfer well to a disc. Mastering engineers were very skilled at getting the best translation to vinyl, and stereo added additional restrictions. In a simplified form, a stereo record could be thought of as having the left channel on one side of the groove and the right channel on the other side of the groove. This works pretty well, but there are some drawbacks, and one of them is out-of-phase material will be translated into a vertical motion of the stylus when you play it back. Too much out-of-phase material and the stylus on playback could be thrown right out of the groove. The record would skip. So recording engineers had to be aware of how much out-of-phase material was being recorded, because if there was too much, the record couldn't be properly tracked on playback. There's no reason why a disc has to be cut laterally, that is, side-to-side motion of the stylus. It could just as easily work vertically. Actually, there are quite a few lacquer discs that were cut vertically. These could not be played on a conventional turntable with a playback cartridge that was expecting a lateral cut, so you had to have a special cartridge to play those back. When I was at WPEN, we had 16-inch Fairchild turntables throughout the building, and the tone arm on those actually had a big turret at the end with 3 selectable playback cartridges. One was a standard groove for playing 78s, the other was microgroove for playing back LPs, and both of those were lateral, and then there was a third head, which was a vertical head and could play back the discs that were cut that way. Too much low-frequency content in the left or right channel could also cause tracking problems, so when discs were mastered, they would roll off the low frequencies into the center. Good mastering engineers would know just how much of that combination of the left and right into center at low frequencies was needed to make a good disc. They could select the roll-off frequency. You can get away with this because our ears are mostly insensitive to direction at the lowest frequencies. That's why you can have a subwoofer, single channel, and fills in all the bass. Actually, in really good listening environments, the low frequencies have a lot more directionality than you might think, but in most situations, it's not that great. If you're starting to wonder how this system of recording music could possibly work well, you're right. Getting it to work well took a lot of skill and experience, not only from the disc mastering engineer, but also from the engineer cutting the original recording. In my studio, we never cut masters. Well, actually, I think I did cut a couple of 45 masters, which were nominally successful, but it really wasn't the same as having somebody that had the right equipment and really knew how to use it. So we didn't do that very often. For one thing, it was only mono, We had no diameter equalization and no variable pitch. As I mentioned before, the groove pitch was set in order to accommodate the length of the material that was going to be recorded. So in a 45, which might be 3.5 minutes long at maximum, you might use a lead screw that has a pitch of, say, 100 grooves per inch. I don't remember the exact number, so I may be way off on that. But just as a comparison, that gives you a sense of how closely spaced they are. But if the song was only 2 minutes long, you could go to a much coarser pitch, maybe 75 grooves per inch, and that allowed you to cut at a higher level. The problem is, as you increase the level, you have to leave enough room in between adjacent grooves. Otherwise, you might hear the sound of the adjacent groove before or after the other material you're listening to. This pre or post echo can be very annoying. So the loudest point in the recording sets the minimum pitch you can use. And sometimes there might be a recording that's pretty quiet, except for one very loud passage, in which case you would use a coarser lead screw than you might normally use, and therefore decrease the amount of time you could fit on a side. More sophisticated lathes had variable pitch, which automatically adjusted the groove spacing depending on the volume of the upcoming audio. They did this by putting a separate playback head on the tape machine, spaced the proper distance away from the normal playback head. This preview head was used to drive a control voltage which controlled the pitch of the recording lathe. That way the grooves could be spaced farther apart as a loud passage approached, so you wouldn't have any of the pre-echo. The main advantage of this system is that it allows you to get a lot more material on the side of a disc because all the quiet places can be spaced much closer together. Most of our disc cutting, though, was for reference mixes and demos. Back in this era, most musicians and producers didn't have reel-to-reel tape machines at home, so it was common to cut them a disc at the end of the session so they'd have something to listen to. Tape cassettes became an option in the early 70s, but they still had a lot of problems and didn't sound very good. The discs actually sounded better at that point. Another problem with tape cassettes is that most players did not run at the same speed. Generally, a player, when it was new, ran a little bit fast, with the assumption that as the mechanism wore down, it would slow down the tape. But this meant that the recording, when transferred to cassette, would sound slightly different pitch and tempo on every machine that you played it back. We actually had several tape cassette recording machines, some with variable speed, and we had a chart above that for all our regular clients, which said which machine and what speed to record them at, so that when they played them back, they'd sound right. But many producers preferred having the disc, because playback turntables were generally fairly close in speed. Also, record companies wanted to hear reference mixes on disc, which I guess gave them a better idea how the final product would sound. And songwriter demos were always submitted to a publisher on a disc back in those days. So we ended up cutting a lot of discs. Our disc lathe was in operation almost every day. Earlier I mentioned the chip, the long ribbon of lacquer that's cut out of the disc as it's being recorded. Without any intervention, this would just pile up on the disc, which could be a major problem as it got thicker and thicker pile of this tangled stuff that sort of looked like steel wool as you cut farther towards the end of the disc. That was one advantage of the inside-out system, because you could just use a paintbrush to gently guide the chip off the outside edge of the disc. But the disc lathe I had a vacuum system, which was used to hold the disc down on the turntable, and also provided a tube that sucked up the chip as it was being cut out of the disc. This went through a long Teflon tube into a glass jar which collected it. And in that glass jar was a little bit of water and some detergent, which helped mat the chip material down so it didn't just pile up inside the jar. As the jar got full, we'd pull out the stuff and just put it in a plastic trash bag and throw it out. But remember, this stuff is cellulose nitrate, which is used as an explosive. It burns very, very rapidly, especially when it's exposed to the air like it was in this chip collection. So you always had to be mindful of what you were doing with that. We never had a problem, but one of my engineers decided it would be fun to see how that burned. So he took the chip collection out of the jar and dried it out and put it in a paper bag. I didn't know about this until after the fact, but he and another engineer took it outside the building. They put the bag in the middle of the road out in front of the studio and lit it. They never did that again. It was quite an explosion and an intense flame, and actually that burned part of the asphalt on the road lasted there for years. Here's a brief outline of what we did when we were cutting a lacquer disc. Now this is coming from a tape, don't forget. What you had to do, especially on an LP or any kind of recording that had multiple songs on it, was put leader tape in between each cut. The length of this leader was standardized in the industry. As I recall, it was about 5 seconds, but you could vary that somewhat depending on the ending of the song before and how the next song started. Normal leader tape is similar to the tape you use for recording, but it has no oxide on it, so it does not record. The problem with this leader tape is that as it passes the playback head, it can cause crackles and pops from static electricity. So for cutting discs, we use paper leader tape. It sounds like it wouldn't be very durable, but actually it held up pretty well if you handled it properly. We cut the discs in a separate room in the studio, which was equipped with a playback tape machine, obviously the disc lathe and all its related equipment, plus some outboard gear that might be needed. So the output of the tape machine went to an equalizer, which we could adjust if we needed to compensate for excessive high frequencies or perhaps other defects in the recording. We didn't actually use it that much. From there, it went to a peak limiter, which allowed us to cut at a much higher level onto the disc. It wasn't a sophisticated limiter like most mastering engineers used, which was frequency selective and did a better job of controlling the high frequencies. From there, it went to the power amp, which was a monstrous thing. It used 4 811A vacuum tubes in push-pull parallel to drive the cutting head. Those vacuum tubes are normally used in transmitters, and 4 of them like that are capable of a kilowatt or more of output power. But at audio frequencies, it was probably half that. As I said before, the cutting heads are very inefficient, so they take a lot of power to drive them, and the amplifier has to have a ton of headroom. The power amp had a plate current meter, which would indicate how much current the tubes were drawing. That sat at a resting level, and I don't know how much, maybe a few hundred milliamps, and it varied slightly with the audio. That gave you a rough sense of the cutting level. But to determine the real cutting level, you had to look at the groove through the microscope. The best way to do this was to make a test cut and then slowly turn the disc by hand under the microscope as you observed how much the groove deviated from side to side. You knew there had to be a certain amount of land in between the adjacent grooves so you wouldn't have a problem on playback. Before you started, you'd pull out a brand new disc and examine it under a bright light, holding it at an angle. This was necessary because occasionally discs would come in that had thin spots in the lacquer, and that could be a problem because the cutting head tracked at a predetermined depth into the lacquer, and if the lacquer was too thin, the stylus might hit the aluminum, which not only ruined the recording, but ruined the stylus as well. The lacquer was semi-transparent, so you could actually see the aluminum underneath. Next, we'd probably cut a test disc and examine it under the microscope to see how it looked, and then take it off and put it on a separate turntable and play it back and listen to it. The amount of current through the heating coil around the stylus affected how much noise there was in the groove. And although this was pretty standardized, sometimes you needed more heat or less heat to get the desired noise level. You probably also record the loudest part of the recording, just a few seconds or whatever it took to be able to hear how the disc was going to sound at that level. You also checked to make sure there wasn't any pre or post echo. If you take a look at a vinyl disc, you'll notice that at the very beginning, there's a spiral that starts at the edge and continues in to where the audio starts. And at that point, the grooves become spaced closely together. On sophisticated disc cutting lathes, this was all automated, but we had to do it manually. And this wasn't hard to do. You just start as far out on the edge as you felt was safe, and then spiraled into a standard point where you would begin the recording. You couldn't start on the very edge of the disc because generally the lacquer was very uneven there, and you risked damaging the stylus. That's why for a lot of mastering, they use discs that are quite a bit larger than the final pressing's going to be. That way they can start to spiral in much farther out, and that way it can be a very clean spiral right from the edge. If there were multiple songs on the disc, you had to do another slight spiral in between the bands, which made it easy to find a particular song on the album. That, too, is easy to do manually. And at the end of the record, you do another spiral all the way in to the minimum diameter. This, too, is a standardized point. Turntables were designed to expect these exact starting and ending points. The problem was, if you just did a spiral, when the playback stylus reached the end of the groove, where you lifted it off the disc, the tone arm would probably just keep going right into the label area. This could damage the playback stylus and certainly made a lot of racket. So you wanted to make sure that the playback stylus was captured before it would run into the label. And to do this, you had to make what was called a locked groove. And this is simply a groove that just goes around without any advancement, so it comes right back to the same point at the end of the rotation. Sounds simple enough. The problem was if you went past the point where the groove was supposed to end and started to cut again into the same groove, you ran the risk of hitting the aluminum and ruining your stylus. So you had to have very good timing and watch the disc as it rotated, so it came right to the point where the groove stopped advancing, and as soon as it hit that point, lift the stylus. Again, on sophisticated lathes, that was all automated, but we had to do it by hand. After the finished disc was cut, we might check it on a turntable if there was any concern about some problem in the cutting process. But generally we avoided that because every play was a little bit of wear on the disc, and when lacquer discs are first cut, they're very soft. The lacquer continues to harden, and the longer it sits, the harder the lacquer will be and the more durable it will become. That also meant that blank discs in storage had a finite shelf life. If you waited too long, the lacquer would be too hard, and it was difficult to cut those cleanly. But any way you looked at it, a lacquer disc did not have the durability of a vinyl disc. Although, if handled properly and played back on quality equipment, they could last for a very long time. At WPEN, the sign-on and sign-off of the station when it went off the air at night and back on in the morning was recorded on a lacquer disc that had been made who knows how many years before I got there, and it still sounded fine. We had labels that were pre-printed with the studio logo, and we could type in the info if we wanted to, but sometimes we didn't even use a label, just use a grease pencil to mark the disc. As I said, I never did any disc mastering, so I'm not an expert on this. But I did spend a lot of time with mastering engineers and watched what they did, cutting the lacquer disc for a master. Good mastering engineers could get the most level on a disc. The concept of loudness wars goes back a long, long time, probably back to the 1930s when the limiter was first invented. So good engineers knew how to keep the loudness up, keep the disc sounding bright and clean, and they were really excellent at what they did. But it was also the responsibility of the recording engineer to record something that could be translated to vinyl effectively. And that meant you not only had to be careful about levels and dynamic range and noise and all those usual things that would apply to any recording, but you also had to be aware of how that recording was going to translate into vinyl. So if you had something that, say, for example, had a hi-hat mixed really high in the mix, you knew that the sound of that hi-hat was going to be really changed when it came out on the vinyl, because the high frequency limiting that had to be put on that to keep the level down to the point where it didn't overcut the disc would mean that the hi-hat would be much lower in volume than your original mix would be. That's just one example, but it helps explain why masters that were cut for vinyl often don't translate very well into a CD or other digital format. You just had to make things sound very different in your monitor speakers in order to make them sound right on the disc. Typical channel isolation from left to right on a disc could be as low as 15 to 20 dB on a cheap turntable. The master tape would probably have well over 70 dB of separation. Whenever I would get a test lacquer disc or a final pressing, I would A/B it with the master tape. The sound was always smaller and the sound stage narrower. Consequently, during mixing, you might have to exaggerate the left and right separation to make it come out properly on the disc. And last, I'll mention a couple of stupid disc cutting tricks, which you might find amusing. This is really arcane stuff that probably nobody knows how to do anymore. But it's possible to cut a disc with two interlaced grooves. In other words, you could put two songs in the same space on the disc. You had to cut the disc with a very wide groove spacing, of course, because you'd have to then go back and do another cut in between those grooves with the other song playing. The tricky part of this was getting the groove to start at the exact right point so that it interlaced perfectly with the existing groove. Obviously, if you ran into the existing groove, you'd ruin the disc and maybe even your stylus. The result was a disc that, depending on where you dropped the needle in, would play one song or the other. It was great for amusement. I read about this, and of course, I had to try it. I spent several hours experimenting on a test disc, finally got the timing to the point where I could usually make it work. I took two songs from an artist friend, one very somber and the other quite frivolous. I cut the disc and gave it to him and asked him to play it. And then I asked him to play it again. I don't remember how many tries it took to get the alternate song, but only 2 or 3. And as you can imagine, hilarity ensued. Some skilled mastering engineers could do this with 3 songs. I never tried that. Here are some of my thoughts on the whole concept of phonograph disc recording. It's certainly a durable medium. With proper storage and minimal play, a vinyl disc will last 100 years or more. Tape is only good for 10 to 20 years generally. CDs probably about the same. And with digital formats, you just have to rely on constantly updating that digital data to the latest format. There's been many changes over the years. 78s, even 12-inch 78s, could only accommodate a little over 3 minutes of music. That's part of the reason why pop songs tend to be in that 3-minute range. LPs have much more capacity, up to 25 minutes per side, depending on the material. Vinyl is arguably the best consumer format ever devised, although high-resolution consumer digital sounds pretty good. And digital, of course, can be a lot more durable. But there's something about the feeling of flying through the groove, especially with headphones, not duplicated in any other medium. The intrinsic distortions in vinyl are much like analog tape or vacuum tubes. It's appealing to us, and we enjoy that sound. To many people, the ability to own a physical object with a cover that allows a lot of meaningful art and information is part of the appeal. The concept of how a disc works is easy for anyone to understand. It's a mechanical system that is obvious to the careful observer. You can see the music in the grooves with only a magnifying glass or a 50 to 100 times microscope. You can play back a disc with a paper cone you make out of a sheet of paper and a pin, which will ruin your disc. So if you want to try it, do it on something you don't care about. But it works. But discs have their problems. Lower dynamic range, more noise, more distortion, reduced stereo separation, and reduced playing time compared to digital formats. Records take up a lot of space compared to the music library on your phone or player. Imagine how much space it would take to put an equivalent number of 12-inch discs on your shelves. For some, it's part of the appeal that there is a lot more physical engagement with vinyl. You have to take the record out of its sleeve, put it on a turntable, put the tone arm down on the record. At the end, take the tone arm off, flip the record over, start over again. It's a lot more involvement rather than just sitting there and letting a player sequence from song to song. You had to learn to listen to your music in 15 to 20-minute chunks. Vinyl, of course, imposes a lot of limitations on the recording process, so the recording engineer has to be aware of what's going to happen to his recording when it's translated to vinyl. I hope the expertise of cutting a lacquer master does not disappear as those experts who are so good at it leave us. I hope they're training people to continue this. This is my take on music recording. I'm Doug Fern. See you next time.